Sige, open tayo ng camp today. Ayan. So, ngayon, si Moya mukhang mahirapan pumasok. Baka yung internet connection niya. But anyways, so yan, dumadami na tayo ngayon di tulad ng mga previous weeks natin. So ngayon nasa week 4 tayo ng ating physical science. Actually, yung lesson natin sa lecture is all about how the properties of matter relate to their chemical structure. So almost 2 weeks to. So part 1 and part 2. Yung part 1 natin ngayon is bond polarity or molecular polarity. O, yung second naman is yung intermolecular forces, which is next week yon. Okay? So, may papakita ko sa inyo na video regarding sa ating polarity of molecules. So, panoorin natin siya.
Welcome to the week 2 of Physical Science for grade 11. For this week, we will be discussing regarding with the polarity of molecules. So stay tuned and be updated to the information that you will gather from this discussion. Once again, I am Sir Feets and welcome to Feets Talks. For this lesson, here are our objectives. Objective number 1 is to identify the factors that affect polarity of molecules. Objective number 2 is to determine the geometry of molecules. And objective number 3 is to differentiate polar and nonpolar molecules. So ready your notes. Also, you can take notes of the important details that you will gather from this lesson. You can also take some screenshots of the important details from this discussion. To begin with our discussion, let's have a review of our previous discussion. Try to remember the following terminologies on your screen. You can pause for a while you are writing your answers. Terminology number 1, Big Bang Theory. Terminology number 2 is nucleosynthesis. And terminology number 3 is stellar evolution. I think you are now ready for the revealing of answer. Once again, you need to define three terminologies from our previous discussion. So the first terminology is Big Bang Theory. You can take note of your answer to your lecture notebook. So let's begin. Big Bang Theory, it is the one of the theories in the formation of the universe which also explains the formation of lighter elements such as hydrogen and helium. So take note of this particular terminology. Second terminology is about nucleosynthesis. Nucleosynthesis, once again, is the process of the formation of atomic nuclei by means of combining protons and neutrons. As you can see to your illustration, that is when nucleosynthesis happens. And the third terminology is stellar evolution. This representation gives you an idea how a star forms. We have two main types of stars. You have the low and medium massive stars and the high massive stars. Between the two types of stars, it will start from a nebula. A nebula will become a main sequence star, a red giant, a planetary nebula, and the white dwarf. For high massive stars, from nebula, it will become a main sequence stars, a red supergiant, supernova, while high massive star will become a neutron star, and a very high massive star will become a black hole. On every stages of stars, it has different processes which involves the formation of heavier elements. So let's start revealing those processes. During the main sequence star stage, nucleosynthesis and proton-proton chain reaction occurs. These particular processes will form the production of helium atom. Eventually, this process will continue until to the formation of red giants. Red giant will conduct the process of triple alpha process and of course the alpha ladder. This will create the heavier elements such as carbon to iron atom. For high massive stars, CNO cycle is happening to the production of more helium atom, followed by the red supergiant, and of course to the supernova, which involve the R process and the S process, which will create heavier elements such as uranium and thorium. Now, let's move to the next part of our discussion. This is let's analyze this. For this activity, you need to predict what will happen to the scenario given. So let's begin. Great. Here are the instruction for this particular activity. Instruction number 1. You need to answer the guide questions. And of course, instruction number 2 is you need to post your answer in the comment bar of the FLMS. So take note of the important details that you will gather from this activity. Here are the following guide questions that you need to answer on the comment bar of the FLMS. First question, what scenario are miscible and immiscible? Second question, why do you think that some substances doesn't mix or dissolve to each other? So I think you are ready now for our particular activity. Once again, take note of the important details that you will gather from this discussion. And then, of course, you need to answer the guide questions on the comment bar of the FLMS. So ready? Let's begin for scenario number 1. What do you think will happen if a water molecule will combine to an oil molecule? Once again, this is scenario number 1. You can pause for a while to take note of the answer for this particular scenario. Let's move on to the next scenario. Scenario number 2. You have a water molecule combined with a vinegar. What do you think will happen to the combination of two substances? Once again, take note of your answer and post it on the comment bar of the FLMS. So I think you are ready for the reveal time of our activity. Once again, on our activity, we have discussed regarding with miscibility and immiscibility. But what is the meaning of miscibility and solubility? Miscibility, it is the ability of liquid solute to dissolve in a liquid solvent. So this will be regarding with the state of matter. Once again, you have three major types of state of matter. You have solid, liquid, and gas. Miscibility and solubility are different according to the state of matter involved to the process. Second one is solubility. It is the ability of solid solute to dissolve in a liquid solvent. If you will observe the difference between the two, miscibility involve two liquid material which are dissolving to each other. While for solubility, there is one solid and one liquid material that are mixing together. Not all materials are soluble nor miscible because of their polarity. But the question is, what is the meaning of polarity and what is the connection of polarity to the miscibility or solubility of a material? So I think you are ready to listen now to our deeper information. So let's dive in. For this day discussion, these are the main concept or main idea that you will encounter. Electronegativity, covalent bonding, bond polarity, and molecular geometry. All of these terms are included to our discussion. So I think you are now ready to dive in. The first concept that you will encounter from this discussion is about bond polarity. But what is the meaning of bond polarity on the first place? Remember, the polarity of the bonds between atoms can be based to the following. First one is about electronegativity and geometrical shape of the molecule. As you can see to the interpretation, bond polarity is about the combination or the attraction of two molecules to each other, forming different substances or different molecules. So the first factor to consider in bond polarity is regarding with electronegativity. Electronegativity is the measure of the relative tendency of an atom to attract electrons itself. Remember that each atom has three main subatomic particles. Those are neutrons, protons, and of course electron. Electron is on the outermost shell of an atom, which involve to the attraction of two molecules to each other. As you can see to the illustration here, you have two hydrogen molecules that are attracting to each other. This particular process or activity is what we call electronegativity. Remember that the higher the value of electronegativity, the more it tends to attract. It means that the more electrons that an atom possess, the higher the possibility that it will attract to others. So as you can see here on your presentation, this is what we call the electronegativity charts. You can also take a screenshot of this particular chart because you can use this to the next presentation. So once again, on this particular presentation, you will see the electronegativity of each elements. So example, you have hydrogen, which has a 2.1 electronegativity, lithium, which has 1 electronegativity, and you also have nickel, which has a 1.9 electronegativity. This is very important, so take note or take a screenshot of this particular chart. Remember that because of electronegativity, bonding is possible from atom to atom because electron is the one responsible for the attraction of two atoms. This lead to covalent bonding. And we have two types of covalent bonding, the polar and the non-polar covalent bonding. So if you will observe to this illustration, you can see an illustration of what is happening during the process of covalent bonding, wherein two atoms are attracted because of their electron negativity. So the first type of covalent bonding is what we call polar bonding. But what is happening on polar covalent bonding? In polar covalent bonding, this occurs when electron pairs are unequally shared. So how we will determine if an atom are unequally shared to each other. So example, we have carbon tetrafluoride or CF4. We have two main elements present on this particular formula. You have carbon and of course fluorine. Carbon has an electronegativity of 2.5 and fluorine has an electronegativity of 4.0. So by performing the mathematical equation of difference, we can convert this one to 4 minus 2.5, and that will be equal to 1.5. This particular value is what we call the electron negativity value. Take note of this one because we can use this throughout of our discussion. As you can see, there is an unequal sharing because when there is an equal sharing, the value should be in zero value. But on this particular example, we doesn't have a zero value. That's why it is an unequal sharing. This separation of charges creates an electric dipole or two poles, wherein it's possess a negative and a positive pole. That's why it calls a dipole because you have the positive pole and the negative pole. Now, how to determine where is the positive pole and the negative pole? To determine the positive and the negative pole in a dipole covalent bonding, you should know what is the lowest En value and the highest En value. Once again, En value, also known as the electronegativity value, can be found in a periodic table of elements or to the previous slide that I presented. Elements with higher En value become the partial negative pole, while the elements with the lower En value becomes the partial positive pole. Take note of this important rule because you can use this throughout of our discussion. Also remember that a polar molecule or a polar covalent bonding is also a dipole. Okay? During the dipole process, it creates two charges of poles, the positive and the negative. Going back to the rule, higher En value become the partial negative pole, and the lower En value becomes the partial positive pole. For you to identify that, you should know first the value of the two elements present, the carbon and the fluorine. Carbon has an En value of 2.5 and fluorine has an En value of 4.0. As you can see, fluorine is the negative one because it possesses a higher En value, and carbon is the positive one because it has a lower En value. The next type of covalent bonding is what we call non-polar covalent bonding. If polar covalent bonding, there is an equal sharing of electron. In non-polar covalent bonding, there is an equal sharing of electrons, or the difference between two atoms are less than zero point 0.5. So higher than zero point 0.5 will conclude as a polar covalent bonding. But lower than zero point 0.5, that is a non-polar covalent bonding. So let's give an example. For this example, you have a hydrogen molecule. Hydrogen molecule has a formula of H2. So you have the element of hydrogen, and hydrogen has an electronegativity of 2.1. Let's transform this data into a mathematical equation. So 2 minus 2 will equals to 0.0. And this will become the En value of this particular molecule. As you can see, the difference between the two elements is 0. Therefore, there is equal sharing of electrons. You can also observe it to the illustration presented. The second factor to consider the polarity of the bond is about the molecular geometry. So we can determine the molecular geometry by means of valence electron pair repulsion theory or VSEPR theory. You can also see an example of molecular geometry on the illustration on your right side. This particular geometry will determine the arrangement of atom and of course the shape of that molecule. Here are the basic shapes of molecules according to VSPER theory. So the first type of shape is a linear molecule. As you can see, it forms a straight line pattern. And the second one is a bent shape. So as you can see, there is a central element and then of course, nagkaroon ng side molecules kaya nagkaroon ng bending. So this particular shape is a bent shape. The third shape is what we call the trigonal planar. In the trigonal planar, it involves four types of elements. You have the central element at the center and of course the side element that you can see on the three side of that particular central element. The fourth type of shape is what we call trigonal bipyramidal. It is called as trigonal because it will form a triangle, and a bipyramidal because we also create or we will form a pyramid from this particular shape. And of course, we have the octahedral because it forms an octagon shape of molecule. And lastly, we have the tetrahedral because it will form a four sides of molecules. So those are the basic shapes of molecules. according to the VSPER theory. Take note of this particular shape. You can take a screenshot of this particular presentation because you can use this throughout of our discussion. But the main question for this discussion is to how to predict molecular geometry. Paano nga ba natin malalaman kung ano ang magiging shape ng isang molecule? So, let's dig in. To determine the molecular geometry of a molecules, you need to follow these particular steps. Step number 1 is to determine what is the central atom in a molecule. So to determine it, this is the least electron negative element. So we have here the example of water molecule or H2O. Once again, we need to identify what is the En value of the element present. For this particular molecule, it has two elements, the hydrogen and of course the oxygen. Hydrogen has an electronegativity of 2.1 and oxygen has an electronegativity of 3.5. So once again, we need to convert this one into a mathematical equation. So you have 3.5 minus 2.1 equals to 1.4 En value. So you can see the En value is higher than 0.5. So therefore, there is an equal sharing of electrons. Take note that water molecule is a polar covalent bond. Also, at the same time, is a dipole because 1.4 En value describes an unequal sharing of electrons. And the least electronegative element is hydrogen, which is the central atom. So as you can see, hydrogen has a 2.1 electronegativity and oxygen has a 3.5 electronegativity. And 2.1 is less than to 3.5. That's why on this particular step, your central atom is hydrogen. After determining the central atom, we can now proceed to the next step. Step number 2 is to count the valence electron of the elements. Valence electron is the outer shell electron in an atom. So the question here is to how to determine it. So definitely, we need to go back to our periodic table. So once again, get your periodic table and follow this particular video to identify what is the valence electron of the elements presented. So as you can see to this presentation, you can see a periodic table of elements. On the periodic table of elements, it has the following numerical identification. This numerical identification on the upper level of each elements are what we called as the group number. As you can see, for hydrogen, it belongs to group 1. Beryllium belongs to group 2. Then you have the succeeding group numbers from 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So on your periodic table of elements, it has an 18 groups. These groups are very important in the determination of the valence electron. So let's reveal. So the valence electron for group number 1 is 1. So therefore, all elements under group 1 has a 1 valence electron. So hydrogen has 1, lithium has 1, sodium has 1, potassium has 1. For group number 2, it has 2 valence electron. While we will skip this one at the middle from 3 to 12, then we will jump into the group number 13 to 18. Group 13 has a 3 valence electron. Group 14 has 4 valence electron, and group 15 has 5 valence electron, and group 16 has 6 valence electron, and 17 has 7 valence electron, and group 18 has 8 valence electron. Remember that group 18 is what we called as the noble gases, except with helium. They're called as noble gases because they are stable because it possesses an 8 valence electron. Let's proceed to the next one. The middle part, the group number 3 to 12, has the following valence electron. Group number 3 has 1. Group number 4 has 2 valence electron. Group number 5 has 3 valence electron. And group number 6 has 4 valence electron. And group 7 has 5 valence electron. Group 8, 6 valence electron. Group 9, 7 valence electron. Group 10, 8 valence electron. Group 11, 1 or 2 valence electron, and group number 12, 2 valence electron. So take note of this particular screen, or you can take a screenshot of this particular presentation. Okay, so since you already know where can be found the valence electron on your periodic table, we can now proceed for step number 2, which is the counting of valence electron. Again, we have the example of water molecule or H2O. Hydrogen, since it belongs to group number 1, it has 1 valence electron. And oxygen belongs to group number 6, therefore, it has a 6 valence electrons. After determining the valence electron of each element, we can now proceed to step number 3. Step number 3 is to create the appropriate Lewis structure of the molecule. Lewis structure is the simplified representation of the valence electron. This is also called as the Lewis dot structure because the dot on each part of the elements are the representation of the valence electron. So let's move to our example. Once again, we have the element hydrogen, which has a 1 valence electron, and oxygen have 6 valence electrons. If we will create Lewis structure for these elements, it will look like this one. For hydrogen, we need to write capital H or the symbol of hydrogen, as you can see to your presentation. Next one is to use a dot to represent the valence electron. Since hydrogen has 1 valence electron, therefore, we can put 1 dot for hydrogen, as you can see to the presentation. The next element is oxygen. So once again, you need to write the chemical symbol of oxygen, followed by the dots representing the 6 valence electron of oxygen. So I have 2 dots and the fourth, fifth, and the sixth valence electron. So as you can see, this will be the structure of oxygen compared to hydrogen. Okay, remember that each dot on the elements represent the number of valence electrons. After creating the Lewis structure of each elements, we can proceed now to the next step. Step number 4 is to follow the octet rule. Octet rule states that for a molecule to become stable, it needs 8 valence electron. So once again, for an element to become a stable, it has an 8 electrons or it should possess an 8 electrons. That's why there is a sharing of electrons para magkaroon ng stable na elements. So once again, we have the example of hydrogen and oxygen. For the oxygen to become stable, it needs 2 valence electron, while hydrogen has only 1 valence electron. Kaya kakailanganin ulit ni oxygen ng isa pang hydrogen element para mabuo niya yung 8 valence electron at para masabing isa siyang octet rule. Likewise, hydrogen needs 7 valence electrons para magkaroon naman ng octet rule or 8 valence electron. Since hydrogen has 1 valence electron, kailangan niya ng suporta ni oxygen na merong 6 valence electron. Combining the two, it will form a particular octet rule. Sir, bakit kulang pa rin? Kasi 1 plus 6 will equals to 7. Sabi nga natin sa octet rule, dapat po 8. That's why it is a polar covalent bonding because there is an equal sharing of electrons. Parang nalugi si hydrogen compare with oxygen. Dinonate or shinare ni hydrogen yung kanyang valence electron kay oxygen para si oxygen ay maging stable. Okay? So let's move on to the presentation. So we have this particular example, which is the water molecule and the oxygen. Of course, the Lewis structure, you can see the 6 dots representing the valence electrons. And of course, you have the hydrogen atom and another hydrogen atom. And now you can see the formation of the octet rule or the 8 valence electron of the oxygen. So if you will count that, that is equals to 8 dots or the 8 valence electron. The 2 valence electron is donated or shared by hydrogen for the oxygen to become stable. After following the octet rule, we can now proceed to the next step. Step number 5 is to determine the shape of the Lewis structure. You may use lines to determine its shapes. Example, so we have still the example of water molecule, the oxygen atom and the 2 hydrogen atom forming the octet rule for oxygen. So we can draw lines to identify what is now the shape of that element. So we have the first line representing the oxygen, and of course, the second line representing the first hydrogen, and the third line representing the second hydrogen element. Then afterwards, we can also draw this particular shape according to this interpretation. So you have here oxygen bending out two side hydrogen, forming this particular shape. Then compare this particular shape to our presentation previously, and of course, predict what is now the shape of this particular molecule. So this molecule is a bent-shaped molecule based to the Lewis structure. On some reasons, we can also identify the pole charges involved. But remember, this one is only for polar covalent. So therefore, you can skip this step if the answer is non-polar covalent. That's why it is a 5.1. If the molecule is a polar covalent, therefore it is a dipole, which have the positive and negative poles. You may represent this using an arrow. Example. So once again, we have hydrogen and of course oxygen. Then following the shape of this particular molecule, and then of course the arrow. The arrow is pointing to oxygen. Why? Why it is pointing to oxygen? Let's reveal it. Again, the end of the arrow represent the negative pole because once again, oxygen have the highest En value, which is 3.5 compared to 2.1 of hydrogen. Next one, the plus sign on the lower level is the representation of the positive pole. Okay, because hydrogen have the lowest En value. So you can draw this particular arrow if the answer is a polar covalent bonding. But if it is non-polar covalent bonding, no need to draw the arrows. And now we can proceed to the final step of this particular process. Step number 6 is to finalize your answer. State the En value, the polarity, the shape, and the drawing of the molecule. So example again, we have the water molecule H2O, and then of course, the table indicating the En value, the polarity, and the shape of that molecule. For the En value of water molecule, that is equivalent to 1.4. While for the polarity, that is a polar covalent at the same time a dipole. And the shape of this molecule is a bent shape. And of course, don't forget to indicate the drawing of that particular molecule. And since this is a polar covalent bonding, don't forget also the arrow symbol representing the positive pole and the negative poles. So after knowing the following information, where we can use this particular information. So what now? So what now? Remember, like dissolves like. Similar also with the term like mixes with like. So what is the connection of these particular quotations to our discussion? Our conclusion is that the polarity of a molecule have an impact to the solubility or miscibility of an element. So therefore, when a substance dissolves to a substance, therefore, it has a similar polarity. While if they cannot dissolve to each other or cannot mix to each other, therefore, it has two different polarity to each other. We can also state that it contradicts the quotation opposite attracts because on this lesson, it proves that similar poles will mix. Therefore, a polar covalent will mix to a polar covalent and non-polar covalent will mix or dissolve to a non-polar covalent. While a polar covalent versus a non-polar covalent will not mix to each other or not miscible or what we called as the immiscibility. So going back to our example on the previous slide, which is which is admissible, immiscible, soluble, or not soluble. And that will be the end of week 2. Thank you so much for listening.
Okay. So yan yung part 1 ng ating lecture for week 4, which is the bond polarity. Okay. So do you have questions so far?